mass energy equivalents. He imagined that a glass of water, for example, could power the city of London or Berlin for 2 weeks. He imagined this before he was able to even prove it. Now, he won his Nobel Peace Prize in 1922 for his discovery of the law of the photoelectric effect, which was a pivotal step towards quantum physics. At the time of Einstein, Newton's math and physics were dominant. And while his math predicted the orbit of all the planets in our solar system very accurately, it was not able to account for the orbit of Mercury. See, Mercury, because of this, Einstein knew there was a flaw in Newton's calculations. Einstein understood that Mercury is so close to the sun that its orbit is greatly affected by the warping of space and time of the sun. Now let's take a look at this orbit. As you can see, it's quite an anomaly. That each precession around the sun, when it gets to perihelion, right, the closest point to the sun, its gravity is flung out, or it has a few arc seconds to the left, or shifts. As you can see, that's quite abnormal. And here's another picture of it. Ultimately, it creates a flower effect, shifting to the left a few arc seconds after each precession. Because of this, Einstein concluded that gravity is the effect of the warping of space and time in the presence of mass. If someone were to say the force of gravity, Einstein would correct him, say, no, it's not the force of gravity, it's the warping of space and time that causes gravity. Objects move, mass distorts the shape of space-time around it. And because of this distortion, it causes a deviation in the fabric of space, and that's why objects actually move around mass. Here's another picture of Mercury. Notice its oval orbit. And notice it also appears to be going downhill, falling into the sun. And it actually is. If it didn't have enough speed to give it the centrifugal force, it would be gobbled up by the sun. Here's what Earth does to space-time around it. It crunches it right up. Because of this deviation, that's why the moon is able to move around us. Now, let me get into Einstein's formula over here on the board. This is his most popular formula that he ever came up with. This is all about relativity. All the geometry of the universe lies in this formula. It took him from 1912 to 1915 to come up with that. He published it November the 25th, 1915. Let's go into it a little bit. And by the way, this is the formula that predicts accurately the precession of the orbit of Mercury. And that's why I maintain if he didn't have Mercury in our solar system, he wouldn't have been able to prove relativity. G Manu, this stands for the shape of space-time. T Manu, this stands for the distribution of mass and energy. This contains the geometry, the math of our universe, and this contains the physics, matter, movement in our universe. The equal sign is the most important thing here because it brings the two worlds together. They have to work together. See, matter tells space-time to curve, space-time tells matter to move. The people that don't think that relativity is important, consider this. Your GPS in your car would be 6 miles off a day if it weren't for relativity, if they didn't understand it. See, on the GPS satellite at 12,500 miles up, time goes more rapidly because it's less gravity. On Earth, time goes more slowly. So time is relative, it's not universal. If they didn't take that into account, well, heck, you wouldn't even have a GPS in your car. Now, Einstein was desperate to get this out and prove his point to the world. He was like the only guy in the world, out of all the people in the world, that really understood this, as you can imagine. It's thinking a little bit out of the box. Now, so what happened? He had to get a solar eclipse. He needed the solar eclipse, which the moon needed to cover up the entire sun, so that he could prove that the light from distant stars bent when it went around the sun because of the weight, the mass of the sun on space-time. So this is what he needed. And finally, in 1919, May of 1919, Arthur Eddington, an English astronomer, and this is an Englishman after World War I, went to the Isle of Principe off the coast of West Africa, took pictures, camped out, took pictures of the eclipse. And took him months to get back, by the way, to London. And on November the 10th, 1919, he, in the front of this statue of Newton at the London, what is it, Astronomical Society, he proclaimed that Einstein was correct, that his theory was correct. The next day, the newspapers went crazy. You know how the media is. Einstein's theory triumphs. All the lights in heaven askew. So he was propelled to the most popular man on the planet at that time, which is pretty extraordinary for a scientist. He was the icon of science from then on. Now, at, let's see, I forgot where I'm going to go next. His best friend was Charlie Chaplin. He said, Charlie Chaplin said to him, look, people love me because they understand what I do. People love you because they don't understand what you do. Would you please explain that? And Einstein just went, dude, I don't know. He died in 1955 at the age of 76. And at the age of 76, he died, and he died without ever really understanding quantum physics. He thought it was spooky, his own words. He never understood black holes. His math told him they had to exist. Now we know they exist. He didn't understand that. He just couldn't imagine it. And then he didn't believe we could split the atom on this planet. Where Leo Szilard visited him in 1939 at Princeton and said, look, we can take the neutrons in uranium, split the protons, and release the energy, cause a chain reaction. And Einstein at that point lit up. He never thought about that. He said, ach, daran habe ich nie gedacht, mein Herr. Which means, dude, I never thought about that. So, anyway, that's because he wrote a letter to President Roosevelt, and that's why we had the Manhattan Project, and that's why we had the bomb first, the atomic bomb. Now, in conclusion, I'd like to just say, I'm already over 7 minutes, but I'm disqualified, but I'll just have fun since I can. In conclusion, let's just say this. Through pure thought and imagination, this man solved the riddle of the universe, which is just extraordinary to me. I just can't get over it. Anybody imagine this type of stuff. It just shows you how valuable thought is if it's correct to mankind. You know, and ultimately, my last sentence is it's Albert's world and we just live in it. Thanks.